Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you two more examples related to finding the limiting value of a given function. So in this example, it is asking you to sketch the graph of this function, and then based on the sketch, you have to explain why the limiting value of this function doesn't exist when x approaches 0. So the starting point to sketch the graph can be made simple if you perhaps consider a simple representation. For example, let's see how the function here looks like if you have, for example, x over x. Okay, so for x over x, what is the difference between this function and that function given here is that I simply ignore the absolute value sign given on the numerator part. Okay, and I hope you can see that if you substitute x equals to 0 into this function, then we will have the issue where this function cannot be computed. Okay, so at x equals to 0, we have to bear in mind that the value is going to be problematic. It is going to be undefined, and when we represent it on a graph, we have to represent it as an open circle at that particular point. Yeah, so if you look at this representation, this actually can be simplified to value of 1. And so if I sketch the graph, so this is the graph, so this is x and this is the gx. You will see that if x is positive value, so we have the sign positive and positive, so the value is going to be equal to 1. Okay, this is at point 0, and we know that at point 0 the value is undefined, so we're going to denote that with open circle. Next, when we consider the negative values of x, so here is negative values of x on this side, so negative values over negative values, so the negative sign will be cancelled and you will also get equals to 1. So here we have the graph continues. I'm sorry, the line is not straight. Let me just erase that part. Okay, so basically, yep, something like this. Okay, so now let us consider this function where you have fx is equal to absolute value of x over x. Okay, so here we have the vertical axis fx, and we have the horizontal axis, which is x. Yeah. Okay, so now if you consider, so based on this representation here, it is easier to visualize how the graph here is going to look like. It's going to be equal to 1 for some reason, and for this reason given here, and you will see that it will just be slightly different because we need to consider the sign of the x values. Okay, so if let's say you consider the values where x here is positive. Okay, so if you consider x greater than 0, because at point 0 is going to be open circle. So when x is greater than 0, we know that the sign is going to be positive, and the sign above here is also going to be positive. So the same values, we are considering the same values and the same sign, and therefore the result of this function is going to be equal to 1. Yeah, so we will have 1 for this part here. This is at point 1. Okay. Right now, if we consider the negative side, then the negative values of x, which is on this side, okay, x being less than 0. So what happened is that the denominator is going to be negative, will be having a negative sign, and the numerator here will be having a positive sign because negative value is going to be transformed to a non-negative since you have this absolute value sign over here. So x here are the same values, so the answer is going to be equal to 1. And in fact, since the positive and negative, these are different signs, so actually the answer is going to be equal to -1. So this is at point -1, And at point 0 here, this is going to be another open circle because it doesn't consider x equals to 0. Okay. Right. Now, based on the graph that I have shown here, we can explain why the limit here doesn't exist. So basically, if you want to see the limit of this function, it exists if the right hand limit is equal to the left hand limit. So now x approaches 0 can be in this direction, left direction, or from the right direction. So let's consider the limit of x approaches 0 from the left direction. And based on this, you can see that if x comes to 0 from the left direction, therefore this is the value of y, or the value of fx. You can see that the value here will come and get closer and closer to the value of, this is actually -1, so the value of -1, yeah. So the answer is going to be -1. Next, if x approaches 0 from the right direction, okay, so we have the limit of x approaches 0 from the right direction. So therefore, y here is going to be in this direction. It is going this direction and it will stop somewhere here. So the answer is going to be equal to 1. And because the left hand limit is not equal to the right hand limit, so we can conclude that therefore limit x approaches 0 fx doesn't exist. Okay, right. Now let us move on to the next example, example 2.11. Here we're going to see whether the limit of the function here exists when x approaches 4. So here we have these two different functions. So basically this function here will be used when you consider x approaching 4 from the right direction, because this is greater than 4. So this function is used for x being greater than 4. And this function is used when x is being less than 4. So we can consider this function if you want to find the left hand limit. So this is the left hand limit and this is the right hand limit. Okay. Right. So simply we can say that if the limit of x approaches 4 from the left of fx is going to be equal to limit x approaches 4 from the left direction, and we're going to take this function into consideration because this is related to x being less than 4. So here we have 8 minus 2x. And you can see that if you plug in the value of 4 into this function here, there is no issue, there is no computation problem, there is no undefined value whatsoever. So we can just simply substitute 4 into this function here. So you will get 8 minus 2 times 4, and the answer is going to be equal to 0. So that is the left hand limit. Now let's look at the right hand limit. So the right hand limit is x approaches 4 from the right direction of, this is fx, and this is a function that we will use because this denotes x greater than 4. So from the right direction, yeah, from the right direction relative to x equals to 4. So here we have limit x approaches 4 from the right direction, and the function here is square root of x minus 4. Again, if you see that if you substitute 4 into x, you will have no problem because the square root of 0 is a 0. The value exists. There is no computational problem. So we can just do direct substitution, and therefore this equals to 4 minus 4. So the square root of 0 is going to be 0. Now, because the left hand limit and the right hand limit is equal, therefore we can say that Okay, therefore since limit x approaches 4 from the left is equal to the value of x approaches 4 from the right direction, which is equal to 0. So limit x approaches 4 fx exists and equals to 0. Okay, so that would be the answer to this example here. Okay, so here, do you think you can sketch the graph of the above function? I'm sure you can. So if we consider the graph, okay, so this is the graph, and this is x, and this is fx. So the point of interest is 1, 2, 3, 4. So this is the point of interest at point 4. Now it says here for x less than 4, the graph is just a linear function, 8 minus 2x. So in this direction, yeah, less than 4, the graph is going to be a linear function, and the graph is going to be to have an intercept at 8. So it is somewhere above. Okay, we can just imagine it is somewhere above here. And since negative 2 is a slope, which is a negative slope, we know that it's coming in this direction more or less. Okay, and at point x equals to 4, it's going to be open circle because the function here is just for x being less than 4. It doesn't include x equals to 4. It doesn't include this. Okay, so therefore when x is exactly 4, this is going to be open circle. It is not defined. Okay, now for this one here, for x greater than 4, okay, for x greater than 4, this is a function where you can see that the basic function of this is fx is equal to square root of x, and we know that this function here will look like this. If you sketch the function, this is how the function looks like. So if you have you introduce a term next to x, which is x minus 4, you know that the graph here is going to be shifted 4 units to the right direction. So 1, 2, 3, 4. So the graph is going to be at this point, something like this. Okay, so therefore we can continue sketch for this one. This is going to sort of look like this, and at point, and since the range here is x greater than 4, therefore we know that for x equals to 4, it's going to be open circle. So this is how the graph is going to look like. Okay, I think that's all for now. Thank you very much for watching.